Welcome, dear students. Now we discuss 2021 question paper multiple choice question mathematical modeling semester 6 University of Calcutta B.Sc honors in mathematics. The question paper 2021 mathematical modeling question 1a. Laplace transform of a function ft is given by, the correct option is 2. F is equal to integration 0 to infinity ft to the power minus st dt, where s is greater than 0. The Laplace transform of a function ft defined for t greater than or equal to 0 real variable t is denoted by capital Fs or by L of ft and is defined by capital Fs equal to 0 to infinity integration e to the power minus st ft dt, provided this infinite integral exists and the parameter s actually is the complex number but may be supposed to be real. Next question 1b. The point x equal to 0 in the standard Bessel equation is a or an, correct option is 2, a regular singular point. Standard Bessel equation x square y double dot plus xy dash plus bracket x square minus n square bracket close into y equal to 0, where n is a real positive number. We can write this y double dash plus 1 by x y dash plus bracket 1 minus n square by x square bracket close y into y equal to 0. Comparing with the equation y double dash plus px y dash plus qx y equal to 0, we get px equals to 1 by x, qx equals to 1 minus n square by x square. Now, px and qx is not differentiable. Actually, this not differentiable at x equal to 0. Because this 1 by x, so at this point x equal to 0, actually discontinuity here and also qx. So point x equal to 0 is a singular point of this differential equation. Now find limit x tends to 0 into x minus 0 bracket close into px. So this x into 1 by x, so equal to 1, this finite value. And limit x tends to 0 bracket x minus 0 whole square qx. Limit x tends to 0, x square 1 minus n square by x square. So x square minus n square. So x tends to 0, so this x is 0, so this is equal to minus n square. So this is also finite. Both exist finitely. Both these limits exist finitely. So the point x equal to 0 is a regular singular point of the standard Bessel's equation. Question 1c. Legendre polynomial P1x is given by, actually this is the x, so correct option is 3. And by Rodriguez formula, P and x equals to 1 by 2 to the power n factorial d and dx to the power n, this bracket x square minus 1 whole to the power n. If n equal to 1, P1, so we put n equal to 1 and simplifying, we get P1x equals to x. So correct option is 3. Question 1d. Using linear congruence method, xn plus 1 equal to 7xn plus 13 in bracket, mod 97 with seed x equal to 0 equal to 105, and 3 random numbers generated are respectively, option is 3. X0 equal to 105, so x1 equal to 7x0 plus 13 modulo 97, so 748 modulo 97, and divide 748 by 97, and residue is 69. X2 equal to 7x1 plus 13 modulo 97, so this 496 modulo 97, and divide 496 by 97, residue is 11. And similarly x equal to 90. So actually these three pseudo random numbers is the 69, 11 and 19. Correct option is 3. Question 1e. Number of extreme points of the convex set x square plus y square less than equal to 1 actually are uncountably infinite. Option 4. Uncountably infinite. Actually, is x square plus y square equal to 1 is circle, unit circle, center at the origin, and this less than equal to means this interior point, uh, including these boundary points on the circumference. This is the convex set S. And the extreme point, these all points on the circumference of a circle x square plus y square equal to 1 are extreme points of the convex set S. So there are infinite number of extreme points. So correct option is 4. Next question, question 1F. If Pnx is Legendre polynomial of degree n, then correct option is 2. Pn minus x equal to minus 1 to the power n Pnx. Now from the generating function of Pnx we have bracket 1 minus 2xt plus t square whole to the power minus half equal to summation n equal to 0 to infinity to the power n Pnx. And putting minus x in place of x in 1 and both sides we get this equation 2. And again putting t minus t in place of t in the equation 1, both sides of equation 1, and we get expression 3. So from 2 and 3, left hand side of 2 and left hand side of 3 are equal. So from the right hand side we can write this summation t to the power n Pn minus x, and this is equal to summation minus 1 to the power n t to the power n Pnx. And comparing, actually equating the coefficients of t to the power n from both sides of 4, we get Pn minus x, this is equal to minus 1 to the power n Pnx. So correct option is 2. If we put x equal to 1 in this expression 5, we get Pn minus 1, actually this minus 1 to the power n, since Pn1 equal to 1. If n is even, then Pn minus x equals to Pnx, and if n is odd, Pn minus x equal to minus Pnx. Next question, 1G. Cars arrive at an automated car wash following Poisson distribution. If their arrival rate is 20 per hour and it takes exactly 2 minutes for a car wash, what is the average waiting time in the line? Correct option is 4 minutes, option 3. And this the queuing model m by 1 to infinity FCFS mean arrival lambda is 20 cars per hour, and the mean service rate mu is 2 minutes for one car, so 30 cars per hour. And the utilization factor rho is equal to lambda by mu is equal to 2 by 3. So the number of cars in Q, that is LQ, is equal to rho square by 1 minus rho, and is equal to 4 by 3 cars. And waiting time in Q is WQ, this is equal to LQ by lambda, is equal to 4 by 3 by 20. So this is equal to 1 by 15 hours, that is equal to 4 minutes. So correct option is 4 minutes. Question 8. The pattern in which the customer change his queue in the initial time and finally join the shortest queue is, correct option is jockeying. But this question is not mathematical. Actually, jockeying can be described as the movement of a waiting customer from one queue to another because of shorter length, or which appears to be moving faster, etc., in anticipation of a shorter delay. This is the jockeying. And balking is the customers deciding not to join the queue if it is too long. This is the balking. And reneging is the customer leave the queue if they have waited too long for service. Leave the queue, but not join to queue is the balking. Leave the queue is the reneging. And collusion is the several customers may cooperate and one of them may stand in the queue to reduce the waiting time. This is the collusion. Next question, I. The set of regular singular points of the ordinary differential equation is correct option is 2. The only 0 x equal to 0 is the regular singular point. The given differential equation is this. You can write this y double dash plus px y dash plus qx y equal to 0. So px equals to minus this divided by x into bracket x cube plus x square minus x minus 1 whole square. So we can write this equal to minus 1 by bracket x minus x plus 1 into x minus 1 whole square. And qx equals to x to the power 4 minus 5x square plus 4 whole divided by x bracket x cube plus x square minus 1 x minus 1 whole square. So after simplification, we get x plus 2 into x minus 2 in whole divided by x into x plus 1 whole cube x minus 1. Clearly, px is not differentiable at x equal to 1 and minus 1 because in the denominator we have factors x plus 1, x minus 1. So x1 and x equal to minus 1 is not differentiable px. And also from the denominator is x equal to 0, x equal to minus 1, x equal to 1. Also pqx is not differentiable all these 3 points. So there are 3 singular points, x equal to 0, x equal to 1, and x equal to minus 1. Now we check whether these singular points are regular or irregular. And for this, first we find limit x tends to 0 x px. So we get this equal to 0, and limit x tends to 0 x square qx is equal to 0. So both limits exist finitely, and so x equal to 0 is a regular singular point. And for x equal to 1, testing for x equal to 1, limit x tends to 1, x minus 1 px, this x tends to 1, so x tends to 1, put it here, x tends to 1, so 1 minus 1, 0, so this tends to infinity, and x tends to 1, x minus 1 whole square qx, and this equal to 0. So both does not exist finitely, because this exists finitely, but this does not exist finitely, infinite actually. So x equal to 1 is an irregular singular point. And for testing x equal to minus 1, limit x tends to minus 1, x minus minus 1 factor this into px is equal to minus 1 by 4, and limit x tends to minus 1, x minus minus 1 whole square qx, actually this is equal to limit x tends to 1 minus 1. So put x equal to minus 1, so x minus 1 plus 1, this is 0. So for this factor, this tends to infinity, so this limit does not exist finitely. So x equal to minus 1 is an irregular singular point of the differential equation. So only x equal to 0 is the only singular point of the given differential equation. Last question, this question J, the zeros of Legendre polynomial of first kind can be, correct option is 3, any real numbers between minus 1 to 1. The Legendre polynomial pkx, actually this is the Legendre function of first kind, is of degree k, and so this has k zeros. Actually these all zeros are simple, real and simple, and distinct this in the interval minus 1 to 1. This p0x equal to 1, p1x equal to x, p2x equal to half bracket 3x square minus 1, and so on, p5x equal to this. So both, so p5x is a degree of 5. So p0x equal to 1, so this minus 1, 1, so p0x equal to 1. So this equal to this 0 is x equal to 1 for this. And p1x equal to x, so this is the line, straight line, this x, so this x equal to 0 is the only 1, 0, this. And p2x equal to half 3x square minus 1, and p2x equals to this this curve, so which cuts the x-axis at this point and this point. So there are two zeros, both real and simple, this two zeros for p2x. And for p3x is a cubic polynomial, so this p3x is this, and cut the x-axis this point and this 0 and this point within the boundary minus 1 to 1, including the boundary within this limit minus 1 to 1. So this 0 real and simple root, these three roots for p3x. And similarly we can find and p4x, p5x, and so on. So correct option is the any real number actually with between minus 1 and 1. Thank you for watching this video.